All right, so here's chapter 4, problem 28. It involves a stone projected at a cliff with height h. Um, the problem gives us an initial velocity, an angle, and a time. And it wants us to find the height of the cliff. It wants us to find the speed of the stone just before it impacts the cliff. And it also wants us to find out the maximum height that the stone reaches above the ground. So the first part, finding the height of the cliff, I wrote some equations down here in blue. We're going to use the first equation there to find the height of the cliff. If you look at that equation, you can see that our y naught is just going to be 0 because the rock is launched from the ground. The y component of the velocity there is going to include that sine theta, and then a is it's just gravitational acceleration, which is downward, so that's going to be a minus g term in there. So I'll write that down right here. I'm going to let this y be our h that we're solving for. And so I'm going to say that h is, y naught is just 0, so we don't have to worry about that. V naught sine theta t minus 1/2 gt squared. So, and again, it's a minus because g is downwards. So I'll plug in my values. The V naught for this one is 44 times sine 69 degrees times 5.41 seconds minus 1/2 9.8 meters per second squared, 5.41 seconds squared. And so for this scenario, that's going to give the cliff height to be 78.8 meters. So there's the cliff height. Now we want to find the velocity, or rather the speed of the stone just before it hits the ground, or just before it hits the top of the cliff, I should say. And so first we need to find each component of the velocity. So we use the second blue equation at the top. In the x direction, there's no acceleration. So the velocity, final velocity in x is going to be equal to the initial velocity in x, which is just v naught cosine theta. In the y direction, though, there is an acceleration. There's g. And so the final velocity in y is going to be given by v naught sine theta minus gt. And so the speed is going to be square root of the sum of the squares of these velocity components. So the speed is going to be the x component squared plus the y component squared. And then we're going to take the square root of that whole thing. We'll plug in some numbers. So V naught again was 44 meters per second. Cosine 69 degrees. Square of that whole thing. V naught again, 44. Sine 69 degrees minus 9.8, 5.41. That whole thing is going to be squared. And again, the square root of that. And so using this for this scenario, the speed at impact is going to be 19.8 meters per second. So now to find the maximum height the stone reaches along its parabolic trajectory, we're going to use this third blue equation. And you might think at first, well, okay, we know the initial velocity, we know the acceleration is g. We don't know the final velocity though, do we? Well, at the topmost point along the stone's trajectory, its velocity for a split second is going to be 0. As the velocity decreases, once it hits the apex of the trajectory, the velocity is going to go from 0, and then it's going to now have a negative value, and it's going to increase as it goes downwards. But for a split second there, we have 0 velocity. So we can use this equation. There's only a single unknown, and that's going to be h. So we'll come down here, and we'll say that our final velocity, as I just said, is going to be 0. The initial velocity, we're in the y direction because it's a height. So it's going to be v naught y squared. And then we're going to be minus 2g. And then instead of delta y, I'm just going to write capital H. And so we can rewrite this a little bit. I'm going to do 2 steps at one time. So I write 2gh over here. And then the y component of the velocity is v naught sine theta, that's squared. And then we can solve for h by dividing by 2g. So we have a v naught sine theta squared divided by 2g. Plugging in my values, I have a 44 times the sine, 69 degrees. That's all squared, divided by 2 times 9.8 meters per second squared. And that's going to give me a height of 86.1 meters. And I don't know if I boxed up this guy right here. So there's that work. For problems like these, I would just suggest finding as many pieces of information about the problem as you can just from the statement itself. So in this problem, it gives us an initial velocity, it gives us an angle, it gives us a time. With the third part of the problem, I was able to pick out that final velocity being 0 just from an understanding of what is happening at the apex of the rock's trajectory. But it's always good to write out all the values that the problem gives you, and maybe anything else that you can extrapolate on your own. It's good to just write that stuff down and really get a sense of the big picture of what's going on. And then you look at your kinematic equations, 3 of which I wrote down, and you can kind of think to yourself, okay, I have some knowns. Are there any equations which only have a single unknown that I can then use to solve? So that's what I did here. And I think that's a great way to approach problems like this. So I hope this was helpful, and have a good one.